7.1 has to do with systems of equations. And before we can actually talk about systems of equations, we have to actually know what a system is. A system is made up of two or more equations with two or more variables. For this purposes, you guys will only have two equations and two variables. So for example, I am going to give you, so we'll come over here, an example. You've got this set bracket. That's what this is called. It's called your set bracket. And so we could have like 3x plus 2y equals 10. And we could have 10x plus 5y equals 15. This right here is your example of a system. You've got equation 1, equation 2, so two or more equations, an x and a y, an x and a y, two unknowns. So the process today is we're going to be figuring out what x and y are, and we're going to do that by graphing. If I were to give you something like 3x minus y, 3x minus y equals 13, and the other equation is 2/5 x minus y equals 0. And the first thing that we're just going to talk about is how do I know if something, what is a solution? How do I solve that? Before, if you had an equation 2x plus 5 equals 10, you would solve that for x. So you'd subtract the 5, and you'd have 2x equals 5, or x equals 5/2. Divide the 2. That's your old thing. Now, if I've got two variables, that means I'm going to have an x and a y as an answer. So my solution is always an ordered pair. Always an ordered pair. So if we've got an x and a y up here, that means my answer is always going to be an x and a y. X comma y is your solution. So we're going to actually solve that. We're going to verify it. They're going to give you 5, 2, and they're going to say, is this a solution to that system I just had up? 3x minus y equals 13, and 2/5 x minus y equals 0. And you're just going to plug it in, your x and your y. So we'll plug it into the first equation, and we'll do 3 times my x is 5. I'll actually make that a 5. My y is 2 equals 13. Well, 3 times 5 is 15. Minus 2 is 13. So that does fulfill the requirement. And then we'll plug it into the second one. 2/5 times 5 minus 2 equals 0. Well, here my 5's can cancel, and I have 2 minus 2, which does equal 0, and it's success. So yes, 5/2 is a solution. Simply take your x and plug it into your x's, your y's, and plug them into your y's. The next thing that we are going to talk about is graphically, how do I solve a system? If I have two equations and two unknowns, that means my solution being an ordered pair is where they cross at. So I'm going to draw a line here, and I am going to put another one right here. Your solution is always where the 2 points cross at. So your solution to a system is where they intersect at. So we intersect at 3, 3. So my solution to this system is 3, 3. So graphically, solution is where your lines cross. And that's it. So you can plug them in to verify what a solution is. And remember, it's always an X and a Y. There's always 2 of them. And graphically, it's where your 2 lines cross, where they intersect at. So let's start with one. They'll give us an example. We'll say y equals x plus 0 and y equals negative 2x minus 3. And we're going to graph both of these on the same coordinate plane. So we'll start with red. And so for equation 1, my y-intercept, remember your b, is at 0. And my slope is 1, that imaginary 1 up there. So I'm going to go up 1, over 1, up 1, over 1, up 1, over 1. And keep that pattern going. Let's see if I can draw this line. Now we're going to do the next one. We'll do it in green. So equation 2, we're going to start at negative 3. And then we're going to go down 2 over 1 because my slope is negative 2. Down 2 over 1. And we're going to make this line. These points intersect each other right here at negative 1, negative 1. So that is your solution. They cross at negative 1, negative 1. Let's do another one. Alright, final example we're going to look at is y equals negative 2x minus 1 and y equals x plus 5. So let's start with negative 1. My slope is negative 2, so we're going to go down 2 over 1, down 2 over 1, down 2 over 1. And draw that line in. The next one is going to start at positive 5. So we're going to go 1, 2, 3, 4, 5. We're going to go up 1 over 1. And then draw that line in very carefully. This crosses right here. And that ordered pair at this point is negative 2, 3. So that is your solution to your system. Okay, so I just said last example a second ago, but I'm changing my mind on that. Because you haven't seen something where y is not already by itself, and that's what we need to work with. So I'm going to give you y equals 1/3 x minus 3, and 2x plus y equals 4. We need to get this y by itself. I need for this awesome little 2x to move. It's going to drag itself over here with the 4 because I want something in slope-intercept form. I need y equals mx plus b. That's my best friend always this chapter. So we're going to subtract that 2x over. And now I've got y equals negative 2x plus 4 when I go to make this graph. So we're going to start with the first one. We're going to go down to negative 3. And since my slope is 1/3, that means I'm going to go up 1 and over to 3. Up 1 and over 3. Up 1 over 3. And we're going to put that line in. That's not very exact on my part. I apologize. And then we're going to throw in this one right here. We're going to go up to 4. And then we're going to go, because my slope is negative 2, my m and my b, we're going to go down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. And draw your line in. As you're putting the dots, your dots should land on top of each other. And that is your solution. Where those two suckers cross each other, that is at negative 3, negative 2, and that is your solution to your system. So, let's recap a little bit. A system is two equations with two variables. And their solution is where the two lines cross. Make sure on your graphs you use y equals mx plus b form. Remember your slope and your y-intercept. Remember your y-intercept is where you start, and this is how you move.